All right, here we are. I'm going to talk about implicit differentiation. This is at the end of chapter 4, and let's start by talking about just the difference between explicit and implicit. So explicit on the left-hand side is what you're used to. It's usually when you have a function that's isolated, a variable, y equals, v equals, f of x equals. And then the right side is usually all just one variable. This is in terms of x, etc. Implicit is when you have kind of x's and y's mingling together. It's very hard to separate them. And so you've got x's and y's, you've got this goofy looking function. You can think of a circle as written implicitly. And we're going to work on trying to take the derivatives of implicit relations today. Can't necessarily say they're functions because something like a circle fails that vertical line test. And then there's also functions that sometimes you have a choice. This looks like an implicit function, but if you multiplied both sides by y and then divided both sides by 3x, sometimes you can take what looks like an implicit and isolate a variable. All right, so let's just do a bunch of examples. I'm going to move quick, but hopefully you can pause it and kind of try some of these and watch it again if you need to. And so some questions you can do kind of either way. And so I'm going to start with this one. The quickest way to find the derivative, so the goal for all these is to find y prime. And remember that's equal to dy dx. So this one you actually could rewrite as 2 over x squared, which is equal to 2x to the negative 2, which is equal to negative 4x to the negative 3, which is the derivative. But that would be the explicit way to do it. So here's our intro into implicit. The implicit idea is if you take the derivative right away. And remember that I'm going to take the derivative with respect to x. We did this a little bit with the trig stuff. Derivative of any constant is 0. But the derivative of the left side, we have a product rule. It's u prime v plus uv prime. And it's with respect to x. So check it out. The derivative of x squared is 2x, because we're working with x's. V is along for the ride. V in this case is y. Plus u, and then v prime is the derivative of y with respect to x. That y prime, that dy shows up in there. So, check it out. I'm now going to try to isolate dy dx. So I'm going to get x squared times dy dx equals negative 2xy. And then if I divide by x squared, I get that dy dx is negative 2y over x. And it's kind of weird here, but if you're looking and you say, well, that's not even the same thing. The weird thing here is that it's negative 2 over x, but y, check it out, I'm boxing it. The y, if you think about it as 2 over x squared, right? This thing that I'm circling in purple is the y. Well, then that's equivalent to negative 4 over x cubed, and that's equivalent to negative 4x to the negative 3, which is this guy. So hopefully your eyebrow's raising a little bit. It's kind of weird. Again, ultimately you're going to try to pick the quickest way, and that way rewriting it at the beginning is much, much quicker. But sometimes implicit's going to be necessary because you can't separate it like we did over here. All right. Let's do a bunch more examples. So let's do another one. Here's a circle with radius 3, if you're curious. And we want to find y prime. Remember, y prime is dy dx. You can write it either way. So I'm going to take the derivative of each term with respect to x. So, jumping right in. The derivative of x squared is 2x. If I did the chain rule on it, it's like 2 times x times the derivative of x. But we usually don't write it because it's equal to 1. Here's the implicit piece. This is the only new piece. The derivative of y squared is 2y. Right, think of it as the derivative of the outside times, got to do the derivative of the inside. There's an extra y prime in there. Derivative of a constant is 0. Now I'm going to isolate y prime. So I got 2y y prime equals negative 2x. Divide by 2y, divide by 2y, and we get y prime equals negative x over y. Now here's the cool thing, and maybe you'll dig on it, but when you do implicit differentiation, that's what this process is called, implicit differentiation, it is okay to have x's and y's in your answer. We've done a lot where when it's explicit, usually you write your answer just in terms of x's, or whatever the variable happens to be. But implicit, this is okay as an answer. What's even more wild here is if you wanted, say, the slope at this point, 0, 3, you would still plug it into your derivative. The slope is going to be negative x over y. Look what that is. That slope is 0. That makes sense. That tangent line right there is going to have a slope of 0. Isn't that awesome? And you could do that at any point you wanted on this circle. Check it out. If you plug it in right here, what would that slope be? It'd be 3 over 0. What? Undefined. Because it's a vertical line. All right, let's do another one here. Now that I've got your curiosity. Here we go. The derivative of this is the derivative of the outside. The inside's along for the ride. Chain rule. I now need to do the derivative of xy. But within that, I have a product rule, because those are variables, they're not numbers. The derivative of that's going to be u prime v plus u v prime. Right, derivative of x is 1, y is along for the ride, and that's what's going to go in here. I don't know why I write my y is different. I got the curly y, I got the straight y, who knows. All right, derivative of this is just 2. Right, because it's respect to x. All right, so we've already done the calculus, and then it all ends with you trying to isolate y prime. So I'm just going to do some quick algebra here. But for me, it's going to be really messy. It's going to be y plus xy prime, and then I divide both sides by that cosine xy. Again, anything that doesn't have a y prime, you move it over here. And then I got xy prime equals this. And then, divide everything by x. Or, multiply everything by 1 over x. And so, however you want to do it, if I times by 1 over x on everything, whether you distribute it in, you make it a fraction, whatever, that's going to be your answer. All right, keep checking the time because YouTube cuts me off at 15 minutes. So let's do one more example. Here we go. Find dy dx for x cubed y to the 5th plus 2x equals 34, and then use it to find the equation of the tangent line. Classic question. So here we go. I want you to see a product rule. Again, you can pause it and absorb it hopefully, but check this out. U prime V plus U V prime, the derivative of y to the fifth with respect to x is going to be 5y to the fourth y prime. 5y to the fourth y prime. Outside, inside. Derivative of 2x is 2. And the derivative of 34, don't let it go, it's going to be 0. I just took the derivative with respect to x of everything. All right, next goal is to, and I got a summary on the last page, is to try to get y prime by itself. So anything that doesn't have a y prime, I'm going to move to the other side. So I'm going to skip some steps. You can kind of follow along. I'm going to minus a 2. I'm going to minus a 3x squared y to the fifth. And then I've got this piece chilling. So I'm going to divide by that piece. So all this stuff cancels out over here. So I really have that y prime, which as a reminder is dy dx by definition, is equal to negative 2 minus 3x squared y to the fifth over 5x cubed y to the fourth. So I'm almost done. So this says, though, to take it an extra step and to find the equation of the tangent line at 1, 2. So my big picture here is my answer is going to be y minus 2, because remember this is x and this is y, equals the derivative, the slope at that point, and then times x minus 1. So I need to find dy dx at this point using my dy dx equation. So usually we plug in the x value, but now it's implicit. So here's the big reveal here in the last minute is I'm going to write this, but wherever there's an x, I got to plug in the x. And wherever there's a y, I got to plug in the y. So again, 5x cubed y to the fourth. I'm plugging in x and I'm plugging in y. I'll try to do this. I feel a little bit rushed. I got 2 to the fifth, 32, so I got minus 3 times 32. Hope I'm not messing up. I don't want to do a retake. I got 2 to the fourth is 16, so I got like 5 times 16. So I got negative 2 minus 96. And then we've got 50 plus, is that 80, I hope? So I got negative 98 over 80. You can simplify that or something, but that is the slope of the tangent line at 1, 2. So final equation of the tangent line is written there for us to see. Whew, I'm out of breath, guys. All right, last page. You can pause the video if you want to, but here's your summary if you need it. To find dy dx for an implicit relation, you differentiate both sides with respect to x and obey the chain rule by making sure you include that dy dx, again also known as y prime, each time you differentiate an expression containing y. And then you're going to isolate dy dx by getting everything that has a dy in it on one side and everything else to the other side. And then sometimes you'll have to factor. But, hey, that was fun. Thanks for watching, and I'll see you guys soon.